So last time we started talking about empirical rule, and now we're going to use our calculator to find the probabilities. Very well. Let us move on to the next page. In next page, we have these questions. Well, the question says 10. Suppose that X represents a random man's height. We want to know the probability that the man is between 72 and 78 inches tall. Using the probability notation, the way that we write it down is that, hey, what is the probability that X, or the person that we randomly selected, his height is in between 72 to 78. Question says you can use the graph to compute the probability, but I'm going to show you how to use your calculator to calculate these probabilities. To use your calculator to find different probabilities, well, these are the process. Just move this enough here so you can see. First, turn on your calculator. If you need to reset your calculator, go to second, pause, go to number 7, reset. You need to reset two things, all RAM and also the defaults. So you need to repeat this process, second plus, go to reset and reset the defaults. Here we go. So we resetted our calculator in order to make sure we don't have extra information here, functions that might mess up our calculations. So again, in this question, we were asked, hey, we have a normal distribution and we want to find the probability that X is in between 72 and 78. What we need is the mean and standard deviation. From previous page, we know that the mean is equal to 69. This is our mu, and the standard deviation is equal to 3. This is from previous page that we calculated the mean and standard deviation. Now we need to find the probability. So to find the probability, we're going to follow these steps. First of all, click on second, then vars. So second vars. So we're going to calculate the probability that X is in between these two numbers. Second vars. Now you need to select the normal CDF, normal cumulative distribution function. Okay, let's go here. So normal CDF. Now you have your lower and upper. The lower is going to be 72. This is your lower, and the upper is 78. These are your bounds, lower bound and upper bound. So lower bound, we're going to write 72, and upper bound, the upper bound The upper limit is 78. The mean is 69. And standard deviation, or sigma, is 3. Here we go. So let us calculate the probability one more time. The probability is 15.73%. If you want to use 2 decimal places, this is our probability. So the probability is 15.73%. This is the probability that you randomly select a person and the height of that person is in between 72 and 78. This is the probability. Almost 16% is the probability that the height is in between 72 and 78. Question 11 says, well, now what is the probability that you randomly select a person and the height of that person is larger than or equal to 75, greater than 75? What if we select a person and we want to know what's the probability that the height is less than or equal to 72, or at most 72? What if we select a person and we want to find the probability that the height is in between 63 and 78? What if we want to calculate the probability that the height is in between 60 and 66? The same process. We're going to use our calculator. The mean and standard deviation are the same. But for these 2 cases, we need to have upper bound as a very large positive number and lower bound as a very small negative number. So I'll show you how to use it. Okay. Second, vars, the same process, normal CDF. Normal CDF, when we're calculating the probability that X is greater than or equal to 75, X is larger than or equal to 75, it means that our lower limit is given. This is our lower limit. So I expect you to ask, then what is my upper limit? Where does X go? In this case, your upper limit can be considered as a very large positive number like 1,000. So when you have your lower limit, automatically take the upper limit to be a large positive number like 1,000, 10,000, 1 million. That's up to you. So in this case, my lower limit is 75. My upper limit, which is not given, you need to write the upper limit yourself as 10,000, 1,000, 1,000,000, totally up to you. Let us use just 1,000 here. The mean is given to us, 69. The standard deviation is 3. And then now we have to do the calculation. The calculation says, well, it's almost 2%, 2.28%, 2.28%. This is the probability that the height of the person is larger than or equal to 75. Okay, what if we want to find the probability that X is less than or equals to 72? It means that our upper limit is given to us. Our upper limit is 72. So what is the lower limit? what is the smallest number that we can assume? So in this case, you can write lower limit to be negative 1,000. So again, the lower limit is not given to us. So we're going to use a very small number like negative 1,000. Let's take a look at our calculator. Well, second vars, so second vars, normal CDF. We're going to follow the same thing, normal CDF. Now our lower limit, we need to write it as negative 1,000. Guys, make sure you do not use subtraction. This is subtraction. It's not a negative sign. For negative sign, you're going to use this negative inside parentheses as the negative sign. So this is negative sign, 1,000. This is your lower limit. Now the upper limit is 72. 72. The mean is 69. Standard deviation is 3. We already have those numbers. Okay, let us do the calculation. To find the probability is, okay, it's 84.13%. 84.13%. This is the probability that the height is less than or equal to 72, or the height is at most 72. Perfect. For part C and D, these two are straightforward. Why is that? Because you have your lower limit and upper limit. We don't have to come up with any positive or negative numbers that we did in part A and B. The lower limit is 63 and the upper limit is 78. Okay, let's take a look at our calculator. Second, vars, normal CDF. My lower limit is 63. My upper limit is 78. My mean stays the same, 69. Standard deviation is 3. So let us do the calculation. Here we go. We have 97.59%. 97.59%. And finally, part D, it says, what is the probability that you randomly select a person and the height of that person is in between 60 to 66? It means that my lower limit is 60, my upper limit is 66. Okay. Second, vars, normal CDF. My lower limit is 60. So my upper limit is 66. Well, my mean is 69. I already have that. My standard deviation is 3. I have that. And then I just need to calculate this probability, which is 15.73%. 15.73%. That's how we calculate the probabilities when we have a normal distribution. Well, we can move on to the next page and check our z-scores based on the data that we have, and then decide about the unusual values. Very well. This is our normal distribution, and we have our data here. We're interested in finding the z values. Recall that the z-score is equal to x minus mean divided by standard deviation. For each of these, you can calculate the z-score, z-value. What is the mean? We know mean is 69. What is standard deviation? Standard deviation is also given to us as 3. Okay, very well. We can calculate the very first z, which is located at the mean. So z is equal to, what is our x? Our x is equal to 69. So 69 minus the mean. But what is mean? Mean is also 69. Divided by standard deviation, 3, which is 0 divided by 3, or 0. So our very first z-score, which is located at the mean, is going to be 0. What about the second z-score? The second z-score is saying that, hey, I have my x, which is 72, minus the mean is 69, divided by standard deviation, which is 3. I get 3 divided by 3, which is equal to 1. So 0, then 1. If I plug in 75 minus 69, 6 divided by 3 is 2. The next z-score is 3. And on the left-hand side of 0, if I plug in 66, I get 66 minus 69, which is -3, divided by 3 is -1. So 0, +1, +2, +3, -1, -2, -3. These are standardized scores. We can convert our data into z values. It helps us eventually to compare data that follows the normal distribution. Here we have the normal distribution for the height of men, and we can convert all of our x values into z values and compare it with another data related to the height. Okay, so what is the next step? Next step is to answer some more questions. Like what? Okay. Like number 13. So let us keep this here. We have said that a value in a normal distribution is unusual. Remember how we define unusual data? If it is larger than 2 standard deviations from the mean. Larger than 2 standard deviations from the mean. 2 standard deviations from the mean. So 2 standard deviations on the right and 2 standard deviations on the left. These values, these heights, are considered to be unusual. So let's take a look at this. What range of heights belongs to unusually tall men? Tall men. We cannot consider left-hand side because it's going to be short. So tall men, 75 or larger. 75 or larger. What z-scores corresponds to these heights? As you can see, the z-score corresponds to 75 is 2. So 2 or larger. What about unusually short men? Okay, unusually short men on the left-hand side. 63 or less. Or less. So what if I ask you about the z-score? The z-score associated to unusually short mean. On the left-hand side, as you can see, it's going to be negative 2, negative number, so negative 2. So you have negative 2 or less. Here we go.